Hello, everyone. This is Kristen Huber, and on behalf of Fivetran and 451 Research, I would like to welcome you and say thanks for attending today's webcast titled Agile Data Warehousing. Leading off the discussion today will be Matt Aslett, who is the Research Director of the Data Platforms and Analytics Practice at 451 Research. Following Matt will be George Fraser, who is CEO at Fivetran. Just a few quick housekeeping items before we get started. Number one, to ask a question, simply type it in the question box on your screen below. We'll answer as many questions as we can during the Q&A session, and we'll respond to all unanswered questions via email after the webcast concludes. Second, this presentation and slides are available for download. And finally, please provide feedback at the end of this webinar. And with that, I'll turn it over to Matt.
Thanks, Kristen. Thanks, everybody, for joining us on today's webinar. So I'm going to kick things off today talking about the topic of Agile data warehousing and describe some of the key trends we see shaping the market. Before I get into that, just briefly to introduce you to 451 Research for anybody who's not come across the company before. So we're an IT research and advisory company. We focus on IT innovation, but we cover the entire industry. But obviously, as I said, the section of that I'm focused on as RD for data platforms and analytics is through the back-end data platforms, data management, and front-end analytics, including increasingly things like machine learning and AI. So we have a couple of thousand clients, which is mostly technology and service providers, corporate advisory, finance, professional services, and IT decision makers. And the last thing I'll point on this slide, in some ways, that perhaps the most important is the next stat: 70,000 plus IT professionals, business users, and consumers in our 451 Alliance research community. So those are people. They're not necessarily direct clients of 451 Research, although some of them work for companies that are, but they are individuals, practitioners out there in the field working with technology as part of their daily working lives and obviously their home lives, and those two increasingly overlapping, and they help shape our view on the world by taking part in interviews and surveys. And as I say, an increasingly important part of 451 Research. And we've got a couple of slides that relate to that group, so you'll see what we mean by that coming up. But starting off today, obviously talking about, as I said, Agile data warehousing, and just to put that in context, I think what we see overall, sort of the bigger picture happening in the market, is a shift towards a lot of companies increasing their investment in data processing, analytics, and as I say, increasingly things like machine learning software as well, with a desire to becoming more, the phrase du jour is data-driven. And what we see is that data and the rapid processing of data obviously always been important, but it's becoming a really key driver in enabling companies to try and grasp the opportunities provided by the bigger sort of picture of digital transformation, and in particular to sort of try and deliver competitive advantage by developing new products and services and increasing their operational efficiency. Another key trend we also see is obviously the cloud is becoming almost kind of the default business environment. Obviously, a lot of organizations embracing, public cloud platforms in particular, but also if we look at, the amount of data that's being generated in the, cloud in inverted commas, but certainly, through software as a service applications, through things like Salesforce and Workday, and then the amount of data that's being generated, particularly, for example, in, the media and advertising industry, through Google and Facebook and online interactions. All this data has been generated through software as a service and cloud applications, and of course that increasingly stored in the cloud as well. And what we see is that, as a result of that and many other trends, that a lot of organizations are increasingly running the business workloads in the cloud by default. There's a number of reasons for that. Obviously, sort of the agility, the ability to spin up and down workloads as required is a key driver. Efficiency, obviously the devil's in the details there, but at the very least, organizations are seeing the opportunity to reduce their upfront costs in terms of investing in physical infrastructure. And also we see is an element of inevitability here. As we said, that an increasing amount of data is being generated in the cloud and stored in the cloud. And in particular, in relation to sort of data processing and analytic workloads, we see that data has gravity. As more data is stored in the cloud, so the data processing workloads are attracted to the cloud as well. So an increasing number of data and analytics workloads and projects being spun up in cloud environments. This gives you a sense. So this is a data point here from that 451 Alliance I talked about earlier. And so we asked respondents earlier this year, those that are already using infrastructure as a service and public cloud, which services and features they were using. And obviously the reason we point this out is you look at the substantial number of these are data and analytics related. Obviously, relational database actually coming out top, followed by data and business analytics. And then you look down the list, data warehousing, NoSQL database, real-time streaming, data processing, machine learning, large-scale batch data transfer. And so, a substantial proportion of the top, what we got here, 10 to a dozen services that people are using in the cloud are data related. And that's something that actually we've seen change a little bit over the last few years. Perhaps the momentum initially was not necessarily with critical data processing applications and infrastructure, but we've seen that shift and that and continuing to do so. Now, if we think about, as I said, the webinar today specifically on the topic of agile data warehousing, and we think about, data processing and analytics, the data warehouse, for many, many years has been kind of the default approach, obviously, to storing enterprise data for analysis. And, for good reason. Obviously, there's a lot of organizations have been successful with data warehousing projects. However, what we've seen is that that it can be somewhat hit and miss. But in particular, traditional approaches to data warehousing, can seem and in many cases are daunting, and you end up with the sort of organisations facing the sort of challenges with sort of illustrated metaphorically in this graphic here. And what we've seen is actually what happens is because of the traditional approaches to creating a data warehouse, they can actually be counterproductive in terms of organizations having the agility to take advantage of the data that they have. So to explain why we say that and what we mean by that, what the key challenge is, illustrated with this slide, it's about the waterfall, methodology. Not only obviously to software development in general, but to in particular the creation of data warehousing environments. What we've seen is that IT has, traditionally been the gatekeeper to analytic insight. And so, with the caveat that this illustration is massively simplified, what we've seen is, the IT professionals, the IT department has traditionally taken on the role of creating reports, creating dashboards, data models, provisioning the data warehouse, and the associated infrastructure in response to requests and demands from line of business users, and the model, the workflow, if you like, that's been taken in relation to that has very much been about model first. The model the data warehouse, design the data warehouse, then extract, transform, load the data, deploy the warehouse into production, and then obviously analyze. And as I said, that even clearly that was a simplification of the process. And what we've seen is that increasingly that traditional sort of waterfall methodology and the sort of model first approach is actually becomes unsuitable for driving real-time decision making on large volumes of live data. And and one of the reasons for that is, and we use here sort of the metaphor of sort of modeling in relation to here, this is an Airfix kit. This is what you get, if you like, with a traditional approach to data warehousing. You get something that's formatted, pre-created for the end user. So there's still some assembly to do, and you can create high performance analytics for the queries basically you knew you wanted to ask when you modeled the data warehouse. And what's the problem with that in particular we've seen organizations come up against is it's inflexible to change, it's inflexible for new data. What that can result in is actually exacerbating the problem that this idea of having a single data warehouse was actually designed to achieve, which is that of data silos. Because what we see happening is if a line of business group have requested a data warehouse, and it's going to take them months to get that data warehouse set up, and then even when they get it set up, they need to change something, and that's going to be another set of months. What they'll often do is, go and do something themselves, either on their desktop or obviously increasingly in the cloud, actually spin up a data mart or start just working with spreadsheets and actually bypass, the IT department in order to just get the answer they're looking for. And that's when you actually, we've seen this in a number of examples where this idea of having this single data warehouse to rule them all actually ends up in creating a bigger problem than existed in the first place. So what's the alternative? Obviously, the title of the webinar is about agile data warehousing, and agility, I think, is the key really to what organizations are looking for when they're looking for a different approach to that data warehouse. And ultimately, if we compare to sort of if the Airfix kit, gives you something that you can quickly assemble, but into something that was prefabricated, what organizations are increasingly looking for is something more like Lego. It got all the bits and pieces, and its ability to assemble them in different ways that's flexible to change, it's flexible to new data, and it's multi-purpose. You can actually serve up multiple applications or projects from a single resource. And again, sort of very much simplified illustration of that. What we see is that increasingly organizations looking to spin up their own data warehouse resources, particularly obviously in the cloud, and spin that up, load the data, and then obviously there is the requirement then to do some transformation on that data once it's in the data warehouse, but very quickly move to analyzing that data themselves. Which doesn't mean necessarily that you cut IT out of the picture completely. There's still obviously a really important role here in terms of managing and configuring and managing that underlying environment, and especially as these projects perhaps move from a tactical one-off project to something that's more strategic and taken into production, and then that's when you start applying more rules around things like data quality and master data management and all those good things. So there is still a role, but it's what we're talking about here is the ability for the individual data analysts or developers, that line of business group, to get up and running very quickly with the project. And this is what we see is essentially sort of driving the change in terms of sort of from an ETL or ELT perspective. In particular, I sort of alluded to this but didn't dwell on it. The shift from instead of extract and transform and then load into the data warehouse, which has been predefined, instead sort of extract and load into the data warehouse and then do the transformation on that data once it's in that data warehousing engine. And what we see is that a number of products and services have spun up, have emerged in recent years that actually are serving this very specific requirement that we see the organizations have developed. And what we see is these services, they're designed specifically for a world of computing resources, as we described, that are designed to be consumed as a service. So if your applications that are generating data are consumed as a service, and increasingly your data warehouse from which you analyze data is there to be consumed as a service, then it makes sense that the extraction and loading services that accompany that would also be consumed as a service. So as I say, it's almost become the default. Also we see, and again I sort of alluded to this there, sort of these services targeted specifically, or primarily at least, at data analysts or developers, not necessarily the IT department, and enabling self-service creation of data pipelines without the need to at least initially call on that IT department to actually configure and deploy a resource for them. The other aspect here is about creating standardized transformation pipelines. that enable those users to take advantage of that target data warehouse to do the SQL-based transformation. As I said, transformation becomes the third aspect, rather than preceding the loading of data into the data warehouse. That ELT approach, places obviously more demand on the data warehouse itself in terms of storage and compute resources. But obviously, as we already talked about, given sort of the agility and at least the potential cost savings that come with the cloud, those are aspects that are not really necessarily in short supply. And the all-important thing here really is, as I mentioned, it's about agility. And what we see is that organizations are looking for greater agility to enable those business users, to empower those business users really to move more quickly from integration to analytics by reducing that time and the complexity associated with creating the data transformation pipelines, and therefore obviously getting the value from that data via the business intelligence projects. So, that's the environment as we see it, as I described, just talking about some of the key trends that we see that are shaping this market. So, from there, I'll hand you over to George, who's going to talk about, obviously, Fivetran, where it fits in the landscape we described, and a little bit more detail on some of those trends we've talked about. And then, we'll continue with some discussion and take Q&A after that. So, for now, thanks very much for your time.
Thanks very much, Matt. That was fantastic. My name is George Fraser. I'm the CEO of Fivetran. Fivetran is a data pipeline company, and I'm going to tell you a little bit about the history of our company, how we got into this business, and the approach to data warehousing that we advocate, which you've already talked about, Agile data warehousing, and how we try to enable that with our product. So Fivetran started in 2013. We are now at over 350 customers. We're at almost 60 employees now. We've grown a lot this year. And we have offices in Oakland, Denver, Dublin, and Bangalore. So we have our dev team is split across California and India, and our sales team is in Oakland, Denver, and we have a small sales team selling to the European market in Dublin. So when we started in the beginning of 2013, we were in the Silicon Valley Startup Accelerator, Y Combinator, right at the beginning. It was two of us, myself and my co-founder, Taylor Brown, and we were initially working on a BI tool. So I did some digging earlier this week and found, you can still find the TechCrunch article about us from that time, and I found some screenshots from that. So you can still see it. This is what we were originally working on and what we launched with on demo day from Y Combinator in 2013. It was kind of a cross between a spreadsheet and a BI tool. We had this special feature where you could do kind of more macroscopic analyses of data. We spent 2013 and much of 2014 iterating on this product. It was not successful. I joke that at the time there were other people who had good new ideas about BI tools, and we were not one of them. However, it did get us into the business that we ultimately ended up in, which is data pipelines. And so what was going on at the same time as we were working on this BI tool is that Amazon launched Redshift. Redshift is a data warehouse. It's a columnar data warehouse. Redshift is a really good data warehouse. It was not the first good data warehouse, but it was the first good data warehouse that was cheap. And it was in the AWS console, and it became the fastest growing product in AWS history. It has a little bit of an unusual provenance. So Redshift was actually developed not by AWS, but by a different company called ParExcel. ParExcel was not the most successful company in the marketplace, but they did build some good technology, and AWS actually bought a fork of their source code. So AWS bought a license to the code and forked it and turned it into Redshift and built it into the AWS console and made it available to anyone with an Amazon account with the push of a button and the number from a credit card. And in 1 year, in its first year of existence, it got over 1,000 customers. As a result of the huge success of Redshift, an ecosystem of tools grew up around it. So not only were many companies adopting Redshift, but many of these companies were technology companies that didn't have a data warehouse before. And so they didn't come in with a lot of the preconceived ideas about how data warehousing had to be done. And so it created a real opportunity for companies with new ideas and new approaches to get in and build tools around Redshift. And in 2015, we became one of those companies. So during that time that we were working on that BI tool, we were using Redshift internally. Our product was powered by Redshift on the inside, although you couldn't access it as the user. And as we worked with people trying to convince them to become our first customers, we discovered that, well, we hadn't really innovated in the area of BI tools, that we had really discovered some new ideas about data pipelines. And in particular, we found that existing data pipelines were built in what seemed to us at the time a very strange way. We kind of didn't know what we didn't know. And when we looked at the way systems like Informatica worked, we were sort of mystified by why people had done things this way. So this diagram illustrates what I like to call the classic ETL paradigm. The idea is that you have a bunch of data sources. Maybe you have some applications like a CRM system like Salesforce or a support desk, some web-based applications that have an API that have some important data in them that you want to use in your analytics. And maybe you have a production database. Maybe you have 20 production databases, as some of our customers do. Maybe you've got some flat files somewhere, some CSVs, maybe some JSON files, and maybe you've got some events coming from your website. And you want to take all this data and you want to use it all in your analytics. The classic approach to this is that you would build a data pipeline that would extract all the data out of all of these systems, and then it would do heavy transformation and modeling of the data before you loaded it into the data warehouse. So very often people would form committees and they would debate what the best schema is to have in their data warehouse, and then they would either write lots of code or they would spend untold hours configuring boxes and lines diagrams in Informatica that would transform the data that comes out of these systems into that schema. And often that involved pre-aggregation. So they would actually summarize the data with sums and averages and counts and reduce the number of rows before they load it into their data warehouse. And the reason that people did a lot of these things is that they were loading the data into slow relational databases. So many of these people, they were using row store databases as their data warehouses. And in the pre-transformation and pre-aggregation was in many ways an optimization in order to make these things work. But if you use a system like Redshift or some of the great data warehouses that have come out in the last couple of years, like Snowflake or BigQuery, all of this is really not necessary. And so when we looked at this problem, it seemed to us that there was a different, obvious way that this should be done, which we now often refer to as ELT or the modern data stack. And the idea is as follows. You start out with the same sources. You've got your Salesforce, your Zendesk, your MySQL database, your Oracle database. You want all this data in your data warehouse for analytics. But instead of forming a committee and deciding on the perfect schema and figuring out how to pre-aggregate the data to make your queries go as fast as possible, you simply load all of the data in its native schema into your data warehouse. So you don't do any transformation, and critically, you don't do any transformation that makes an assumption about what kind of queries you're going to want to do later. Because getting back to that pre-planned airplane model metaphor that Matt talked about before, the whole problem with the left side of the screen is that when you build all these transformations as part of your ETL pipeline, you're making assumptions about what kinds of queries you're going to want to do later. And you're eventually going to discover that you want to do something that you didn't anticipate, and it's going to be a big problem. The approach that we took when we built our product, and the approach we encourage everyone to take when they construct their data warehouse, is this ELT workflow on the right. So the idea is there's still going to be transformation of the data. Like if we pull data out of Salesforce, data comes out of Salesforce in JSON format. We're not going to load JSON into your data warehouse. We're going to, unpack those API responses. Sometimes this can get quite complicated. If you take Zendesk, for example, their API is kind of crazy. The data comes out in a really weird format. We're still gonna organize that data in a schema that makes sense for that data source. So we're going to do transformation, but we're not going to do any transformation that makes an assumption about what kind of analysis you're going to want to do later. We're going to load the data into your data warehouse in a schema that will work for any use case that is native to that data source. It's typically a normalized schema. And then you're still going to have to do transformation. The need for that doesn't go away, but you're just going to do the transformation in the data warehouse. And this is a much better workflow because you still have the original untransformed data sitting next to the transformed data inside your warehouse. And that's going to be really, really important in two scenarios. One is when things go wrong, and things will go wrong, because you still have the original data sitting there, it's much easier to troubleshoot. And the other scenario where this approach really shines is when you change your mind about what you want to do. And that will also happen. When you change your mind about what kinds of queries you want to run, because you still have all the original data in its native schema, you're going to be able to quickly iterate. And that's the really agile part of this. So the key enabling technology that allows this approach to work is these powerful columnar data warehouses. You couldn't have done this with a data warehouse that is too slow or too expensive. And that's why the rise of Redshift was so important for enabling this workflow. Like I said, Redshift was really the first data warehouse that was both fast and cheap. And over the last few years, a new generation of BI tools has grown up at the end of this pipeline that are designed to leverage these fast columnar data warehouses. BI tools like Looker that leave the data in your warehouse that don't contain any kind of cube aggregation layer inside of them that are designed to enable this workflow. So we took this approach to data warehousing. As part of this, we did something that was very unusual for a data pipeline product, which is that we did automatic schema migrations. So when you say, I'm going to have a first stage of my data pipeline, which is going to be an ELT workflow, it's not going to make any assumptions about how I'm going to want to query this data, and it's going to be a standardized product that I buy from a data pipeline company, Fivetran. You have to decide what to do when the source schema changes. And the source schema will change. So when you're pulling data from Salesforce, tomorrow somebody is going to go into Salesforce and make a new custom field, or they're going to go and change the type of a custom field. I remember in the early days, we had customers who perplexingly would change the length of their string fields like every week. They'd have a string field that had a 100-character limit, and then they'd change it to 150, and then they'd change it to 200. So you have to contend, if you're building an ELT workflow, with all kinds of schema changes that are coming in from the source. In the traditional approach, you would reconvene the schema committee, decide whether this new field was really important, decide whether this type change was really needed, or whether you could just coerce the data back to the old type, and you just keep updating your dimensional data model. But it was a big process. It could take months when you had a change in the source to actually get that change into the data warehouse. What we did, which was really different and kind of radical, is that we automatically propagate changes to the data warehouse. And internally, just by the way, this is actually the hardest part of our product, getting this right. So this is a slide from our sales deck that we showed to prospects, trying to explain to them how we do this and how it's different than maybe what they expect from other tools. So when you add a column in the source, that's what's represented on the left, we will simply add that column to the data warehouse. If you remove a column from the source, we won't actually remove it from the data warehouse. We'll leave it there because there are scenarios where you actually want to keep that historical data, and in general, it's best to not delete things. When you change the type of a column in the source, and this is the hardest part, we will actually migrate the data in your data warehouse. So we'll create a new column, we'll coerce all the old data to the new type and copy it over, and then we'll do this sort of switcheroo where we rename the columns, and you end up with the column type changed in your data warehouse. Lastly, if you add an object in the source, obviously we'll add a table in your data warehouse. And if you remove an object, just like if you remove a column, we will simply leave it there. So we support over 60 data sources now. We originally were Salesforce to Redshift. That was our first customer. But now we support over 60 data sources. We support all the major data warehouses. We support 4 basic categories of data sources. All the applications you see on the left, that's kind of the bread and butter. We also support all the major support file stores like S3 and even FTP data sources, and you can send us events directly from your website. So using a product like Fivetran, instead of convening a schema committee and taking months to build your data warehouse, you can put together 5 to 6 of these data sources in 1 week. You can write some views that sit on top of the schema we deliver, and even have your most important analytics working in production in the first week of your data warehouse, and then you can iterate on that. And that's the Agile approach that we advocate, that we try to enable with our product. And we've had really good success over the last couple of years, and we're just continuing to grow and continuing to add data sources. And that's all I've got.
Great. Thanks, George. And yeah, so we'll open up now, obviously, for questions from the audience. So, if you've got any questions based on what myself and George talked about, please do put those in on the panel. It should be on the right-hand side of your screen. And but as those questions come in, I had one question I wanted to ask George. I mean, we both talked about sort of the need, the fact that data pipelines don't necessarily need to be customizable, and enterprises realizing that. And you talked about the technical reasons for that. I was wondering if you got any sort of examples you can talk about some more sort of the business advantages of that from customers, and what that fact has enabled them to do or to do differently.
Sure. Yeah. Data pipeline customization is one of those things that it's funny. Customers will tell you they need it, but it's one of those times where you have to not always listen. It turns out that if you go to someone and they say, I need to customize the data pipeline. I need my Salesforce columns to end in _C, or I need them to not end in _C, or whatever it is. It turns out if you go back to them and you say, well, I can give you a data pipeline that's not customizable. However, it will be working tomorrow. They say, you know what? Maybe that customization wasn't so important. So we find that the standardized data pipeline approach really works well. It has a bunch of other ancillary advantages, which is it's really fast to set up. You kind of aggregate the learnings across many customers. So because we have lots of people who are using each of these connectors, you're not the only one getting that schema. You benefit from the feedback that we've gotten from many people. And I should point out 2 things. One is that even though the schemas are standardized, we do support custom fields. So like if you have custom fields in Salesforce, we will map those custom fields automatically. And a lot of this doesn't really apply to databases. Databases, the schema is inherently fully custom, and we just map everything that we see into the target. But for apps, using standardized schemas has a lot of advantages. Most of all, that you kind of aggregate the learnings across the entire customer base rather than everyone having to rediscover the API over and over and over. So Matt, one of the things that I've been thinking about a lot this year is if you read the original descriptions by Bill Inman, the guy who coined the term data warehouse, a lot of what he describes is really an ELT workflow. He describes, landing data and normalized schemas, even though this was in the 80s, and the databases were a lot slower then. Still, a lot of the approach he lays out involves landing data in normalized schemas, building denormalized data marts. It's basically an ELT approach going way back. And somehow we got off that path. Somehow the idea of the ETL waterfall became the standard. And I'm just wondering, as somebody who's been in this space for a while, what do you think about that? How do you think that happened?
Yeah, it's interesting. I should say, I have been in this space for a while, but certainly by the time I sort of entered this space, it was ETL had already sort of become the default. But it's interesting to sort of think about why that is, and I think you touched on this yourself actually in your slides in terms of obviously the relative cost and performance obviously of some of those early data warehousing systems. So I think it wasn't so much that you couldn't do ELT, but obviously the cycles available in those systems were at a premium, and it was expensive, obviously, to run workloads on them. And so I think hence a lot of organizations started to sort of offload some of that the ETL or obviously the transformation workloads into a separate environment. And I think I could see sort of almost a snowball effect, because clearly then a whole sort of industry sprung up around of transformation specialists, each competing with their different approaches to improve the transformation, but obviously doing it on not a standalone basis, but obviously as a separate layer. So I think that that's at least one of the reasons I think why we saw that happen. And clearly, as it's become less expensive to run those data warehousing environments, both obviously cloud especially, but also on premises as well. I think we have seen that the pendulum sort of swing back the other day. More and more of the actual the analytics and the transformation happening in the database, and obviously as we've described that swinging back towards sort of ELT. So there's probably much more to it than that, but that's sort of my take on it from what we've seen and what we hear from customers and how they're thinking about the different choices that they have.
Yeah, what you say about vendors springing up, competing on transformation features really rings true for me. It's a funny thing when being a vendor in this space, we see this, that there's always the temptation to keep adding features to win the head-to-head sales slides. It can definitely be, for us as a company that is all about automation, it can definitely, you can feel that when you're in competitive sales, because we compete with other data pipelines, and you go up against someone and they have this long list of transformation features, and you say, well, my feature is I don't have any of those things, that it just happens under the hood, and this is the feature of my product is that this isn't available. It can be difficult to go down that road, or there can be a temptation always to add those things. So I totally get how that can happen. I think for us, we've kind of stayed true to our religion of ELT, and we just advocate that with every customer and every sale. But I totally get how, especially the vendor ecosystem, can kind of go down that path of more and more and more transformation features without asking the question, are these features things that we really want to have?
Right. And the other thing, of course, I should have mentioned was, as well as the vendor ecosystem, clearly there became, it was created a job role for, the data management professional, the ETL engineer. And so, for Stockton, it was kind of in that person's interest for that to remain, a distinct job role. I think, that I've mentioned this in terms of what we see partly changing here is, the sort of services, Fivetran and others are being used not by necessarily, at least by those kind of people in those roles, but by data analysts and developers, and so that there isn't a distinct requirement for a role just to do transformation. It's something that is done as in the course of a larger project.
Yeah, the funny thing we see with job roles is that as more and more people switch to this approach of landing the data in a normalized schema using an automated tool that doesn't really require any maintenance, you still have to do those transformations. As I mentioned, you're just doing them in the warehouse, and that means typically you're doing them using SQL. So SQL is becoming more and more important, which is funny because it's kind of back to the future. Like I feel like SQL was waning for a while there, in favor of Hadoop-based technologies and other programming languages, but from our perspective, it seems like it's on the upswing again. It's taking back over. Do you perceive that as well?
Yeah, definitely. I mean, I would say I think this is something we've talked about a lot. That actually, although obviously that NoSQL, it was provocatively named, and there was perhaps some organizations particularly obviously in California, who started to do things very differently. But obviously, most of the incumbent enterprises, nobody gave up SQL, and they'd start making you think differently about their tools and technologies. But SQL never went away. But yeah, there's definitely. Let's say I think we've been reminded of the importance of SQL and its flexibility for doing the sort of things you talked about. Yeah, and it never disappeared, but certainly perhaps it was overlooked to some extent for a little while, and certainly that's not the case right now.
Mm-hmm. Yep. So another thing that becomes more and more important as more and more of the transformation moves to the data warehouse is BI tools.
Right.
BI tools it's like as we kind of abdicate the role of transformation, in some ways, BI tools have to take that on, and so it puts more pressure on them to be able to handle that. Do you see that playing out in the evolution of existing BI tools and new BI tools emerging that are more focused on solving that problem?
Yeah, I think we've certainly seen an element of that. Obviously, there's data preparation and transformation and aggregation as part of that being increasingly available in a lot of business intelligence tools. Obviously, whether you're using an enterprise is using a standalone environment for that, or depends on their choice. But yeah, that functionality increasingly become available. And we talk about we actually sort of recently recategorized our sort of our view of the analytics market, and in that we talk about analytics platforms and what we think, one of the things that differentiates an analytics platform from an analytics tool is things like, data preparation and aggregation and transformation functionality. So definitely, as those environments mature and especially as obviously those vendors look to, especially become more strategically important to their enterprise customers, we see them take on more and more of that functionality. Definitely, yeah.
Data preparation is a funny space. I have to admit to being a little bit of a skeptic of some of the things that have happened in data preparation in the last couple of years, which may sound strange because I talk about the importance of doing transformation in the data warehouse. But if you look at, there's been a lot of activity around data wrangling tools. There have been features that have been added to Tableau, and there's Trifacta, which really kind of got this rolling. If you look at a lot of those tools, they spend a lot of sort of feature energy on like fine-grained fix-up, like data cleanup tasks, splitting strings and removing white space and replacing empty string with null and stuff like that, as opposed to sort of macro transformation, like doing joins and aggregations. And my experience has been that macro transformation is really the important thing, and that those sort of fine-grained transformations, at least from our perspective, those kinds of small data integrity issues tend to be the result just of bad data pipelines. And Fivetran customers generally don't have a lot of those problems simply because we spend so much effort on our data pipelines. We don't deliver, empty strings and these kind of random fine-grained problems. So from where I stand, I have not seen so much of the use case of that data wrangling tool. It's really the SQL joins and aggregations that are needed. But I'm curious what you think about that. How do data wrangling tools fit into this space?
Yeah, I mean, it's interesting actually. Whilst we tend to sort of group all of those sort of offerings together under sort of the data preparation category, which obviously they've all got serving an overall similar purpose. Actually, I do think there are some differences when you look at the tools and details in terms of those that are actually primarily aimed at more data analyst users versus those. Some of them are actually still aimed at that traditional sort of data integration, professional sort of role, and so therefore you get different functionality, obviously, designed for those different roles. So, it is a good point. And I think what are the interesting things about this. The data management market right now, which obviously for a long time it wasn't the most interesting sector of the market. Let's say that is that there's a whole bunch of different products and services that are available and focused on different aspects of. I think we talk a lot that there's multiple threads happening right now, multiple trends that are driving change in this industry, and sometimes you see those overlapping, sometimes you see vendors are focused on a very specific aspect of that, and it's very interesting, I think, to see, or it will be very interesting to see how this all evolves over time, and how some of these trends begin to, obviously, come together, and others will encourage, and cause some of the startups in this space to bang up against one another. So I think it's going to be definitely continue to be an interesting space for a while. Mm-hmm. You talked there about obviously the the workflow aspect to this, and one of the things I was interested in, because we see a lot of emerging interest, if you like, in something like specifically Apache Airflow, but there are other projects along the same lines in terms of sort of orchestrating transformations into the data warehouse. So I was interested to get your take on that, and how the extent you see that's sort of complementary to what you're doing, and how those two can work together.
Yeah, so that is a task that definitely needs to get done for some companies. We do, so basically, we deliver the data in a normalized schema, and we say if you need to transform the data, you should do it in the data warehouse. But in order to accomplish that, sometimes you're going to need an orchestration tool like Airflow, which is, basically that schedules SQL queries to run when the source data has changed, run a query, save the result somewhere. I will say that we always encourage people to start with views. You should always start just using create view. These are logical views, not materialized views, and it's simply a query that gets stored in the database. You can reference the query, and the transformation will get done at runtime. At Fivetran, we're heavy users of data in our data warehouse. We still have not created our first materialized view. We are still running entirely on logical views, and a lot of people can get along with just logical views, and they have a lot of advantages. They're always up to date. You don't have another system that you have to worry about. However, if you get really large data sizes and complex joins, you will need to actually do transformation that gets stored, physical transformation in your data warehouse. And for that, you're going to want to adopt an orchestration tool. A lot of companies these days are adopting Airflow. Airflow is a little bit of a complicated creature. It was designed to do many things, including doing ETL. But we have seen several of our customers with the largest data sets use Airflow successfully to basically schedule SQL queries to run after Fivetran delivers the data and store the data back into the data warehouse.
Great. And I'm just going to turn now. I think that we've got a few questions that have come in from the audience. So I'll turn to those. So George, one of the questions, So are you talking about here doing a full replace of the data when uploading all the data? I guess that refers to one of the slides you were talking about the different approaches to obviously uploading and data. You're talking about full replace? I guess there's different approaches you can take to that.
Yeah, so we do not do a full replace. There are some data pipelines. Often when people build data pipelines themselves, they'll do it this way. They will reload all the data from the source every time, usually once a day, and just replace everything in the data warehouse. For us, that would be impossible because many of these data warehouses we support will not give you data fast enough for you to do that. It would take you more than 24 hours to get all of your data out of a large Salesforce account, for example. And so all of our data pipelines are incremental. It is much harder to build correct incremental data pipelines. That's why often people who are building in-house data pipelines will just do full replace. To build incremental data pipelines correctly is not easy. However, because it's our whole business, because there are many customers using each of these pipelines, it's worth it for us to put in the effort. So there is no trick. We just spend a lot of time figuring out all the little details of the incremental update rules of these systems, and we will actually, update your data warehouse incrementally on a up to every 5-minute schedule if your data warehouse is fast enough to keep up. And it kind of creates the illusion that your data warehouse is just connected to the underlying data source. It feels like you're just querying the original data source, even though in reality, behind the curtain, there's Fivetran madly shuffling little incremental updates over to your data warehouse all the time.
Right, and I guess, so one of the other questions we got was how's the copy of the data handled when fields are in a row are updated in the application, but I guess that you covered that there unless there's anything specific.
Yeah. I mean, we try to we try to create the illusion that you're just querying the original data. So when there are updates in the source, we just map the updates to the destination. It can get quite tricky. Like if you look, for example, at MySQL, MySQL gives you incremental updates in the binary log, which is an internal format of MySQL, and they actually give you cell by cell diffs. When you do an update in the MySQL database, what we see is actually just the one value that changed and the primary key of that row, and that's it. And the same is true for MongoDB, the same is true for Oracle, the same is true actually for Marketo. There are several data sources that work like this. And in order to merge these into your data warehouse, we have to generate these kind of crazy update queries that sort of merge the diff into your data warehouse. But it works great. It's very well tested. It's been in production for years. But this stuff is not for the faint of heart. Right,
absolutely. Okay. One other question we got here, I'll read the question, see what you think. So can you comment on your experience on data mapping to business data domains to be able to gain insight from the landed data?
Yeah, I mean, this is a really important subject. What kind of, in a way, this question is, what do these transforms look like in the data warehouse? This is really customer specific, so it really depends on the company. We don't really get involved with this as a product. We kind of say, we're going to land the data is going to be right, the data is going to be updated all the time, and it's up to you what you want to do with it. But obviously, this is a really important task that everyone approaches differently. I think a lot of it depends on the data source. So if you're pulling data from Salesforce, and your Salesforce is not too crazy, you haven't had too many consultants go nuts in there, oftentimes the data model will be pretty good. And you can basically just write some SQL queries for your BI tool and you're good to go. And the same can be true of a database. If the database schema is pretty close, sometimes the data source is pretty close to what you want, and this is not a huge task. Sometimes the opposite is true. Sometimes you have to do a ton of work sitting down and studying the schema and figuring out what the right transformation rules are, which basically comes down to views of some kind, materialized or otherwise. The thing I will say is that taking an iterative approach to this is the right approach. You will not get, answering that question, how do I map the original schema to my business data domains to be able to really get valuable insights, that is a really hard question. You will not get that right on the first try. And so the right thing to do there is to take an iterative approach, answer your most important questions first, put it out to your company, see how it goes, and then iterate.
Great. And one more question here, which is well, potentially interesting one. What is your thought with transforming data warehouses to a decentralized, immutable blockchain? One thing that eliminates the need for building history as a process. Just my quick comment on that would be, yeah, it may do that, but it also then makes things very difficult in terms of sort of updating and deleting data. I think well, I would leave my comment at that and then see what your thoughts are.
Blockchains have no relevance to data warehouses. I will start by saying that. We talk about columnar data warehouses and how much faster they were than row stores for queries. Like, blockchains are in a different universe of performance. They are way too slow to do any kind of data warehousing on them. History is an important feature that you sometimes want to have in your data warehouse. You want to record the complete history of changes to a table, not just the current status. It is something we have been working on at Fivetran. So right now, as I said, we the data in the destination is just a mirror image of the data in the source. We have been working hard internally on building an alternate mode where we will actually retain the entire history of changes. And we are going to roll that out this year across select data sources. So that'll be true for databases, that'll be true for Salesforce and NetSuite and other things that look like databases. And then for some data sources, like web events and things, they inherently contain history. Even a lot of apps actually internally inherently contain like history tracking tables. So we are gonna have a solution to that problem for recording history. There's kind of going to be two solutions. For apps, it'll be, when we already have this for many of them, built-in history tables. For databases and database-like things, there's basically just going to be a new mode for Fivetran, which is retain history mode. And if you need both, you will just connect the same database twice, once in live mode and once in history mode, and then you'll have both schemas. But no blockchain.
Great. Well, thank you so much, Matt and George. That was a great discussion today. As a quick reminder, the on-demand replay will be available on Bright Talk soon. And on behalf of Fivetran and 451 Research, thank you so much for attending and have a great day.